Hello, hi, good morning, my dear students. Today I am here to deal with the chemistry concepts. Myself, I am Ravi Kumar Fadagli. Today we will start a very new chapter, that is chemical kinetics. So soon we will begin with the new chapter. So chemical kinetics. Before we move to the definition of chemical kinetics, let me tell you, you are very much familiar about the chemical kinetics. Unknowingly, you know everything, but scientifically you are going to study what is chemical kinetics and all. So before we know the definition and all the concepts, why we need to know the chemical kinetics? Because it's going to explain some of the very important concepts in the day-to-day life. That is, main point is formation of reaction. Here formation of reaction is nothing but if some of the reactions are taking place, how it takes, whether it is forward reaction happens or not, whether the reaction is produces or not. And second thing is the rate of the reaction. If the rate of the reaction is nothing but how much time the reaction needs to complete that reaction, that is called as rate of reaction. And next one is rapidly spoiling of food. We know that almost all of the food should spoil at some time, but some of the food are spoiling very soon and some of the foods are spoils later, means it need duration is more. So why the some of foods are spoiling very early? Why? What is the reason? Means the reaction taking place of spoiling is faster in some of the food. Why it is happening? This all explains by the chemical kinetic. Similarly, next one is raw material used in the dental to fill the teeth. We know that in the dentist are using some of the materials, so that initially they are in powder shape. Soon after mixing some of the chemicals, by filling that powder compounds are going to be very much stronger in the structure. So it means which is that elements or which is that compound are used so that that compound becomes strong in the structure. So it means the formation of that solid compound is very much faster, means it in a very short time it's going to be a strongest compound. Why it is happening very much soon? And last one is the burning of fuel in a automobile engine. So here we know that some of the vehicles are giving more mileage and some are giving the less mileage, particularly while rising the accelerator. Means the burning of oil is depends on the running of engine, how it's running. Some of the engines are consumes less, at what time the burning of fuel depends. These all are going to be explained by the chemical kinetics. So let's begin. The chemical kinetic is nothing but it is the branch of chemistry which deals with the study of rate of chemical reaction and its mechanism. So it means that we are knowing that kinetic is nothing but it is a movement when the reaction is going to be a producer product, that movement of reactant to the product, that is called as mechanism. I hope you are very much familiar about the thermodynamics in first PhD. It is possible to convert a diamond into the graphite. These concepts explain by thermodynamics, whereas chemical kinetics it also explains rate of chemical reaction, means how much time needs to convert the diamond into the graphite. And not only the rate of reaction, it also explains about the factors which are influencing for the rate of reaction. It means what are the criteria needed to increase the conversion of diamond into the graphite. This is nothing but commonly the catalyst, pressure and temperature. We are oftenly using the word rate of reaction. Rate is nothing but it is simply the speed. So just look at that reactions. When silver nitrate reacts with the sodium chloride, it very soon product formed as silver chloride and sodium nitrate, means the reaction is undergo the fast reaction. Similarly, the rusting of iron is a slow reaction, it's not a fast. We can't able to justify where the rusting is taking place, means it is takes very much slow process. The next one is the hydrolysis of starch and inversion of sugarcane, means the conversion of sugarcane into the glucose and sucrose. it is a moderate reaction, means generally it is not too much slow and it is not so faster. In between, moderately the reaction takes place. Here we are observing that some of the reactions are very much fast, some of the reactions are slow, and some are moderate. Why these are undergo different time of formation? This is nothing but it explains about the rate of reaction. We can have some still more understanding of rate of reaction. Just to look at this one, here there are A and B. Are think that these are the two fellows, means two persons. A and B, after 5 minutes they are undergo the displacement. The position of A and B, they are different, means after 5 minutes the B person reached more distance than that of the A person. So it means which one is having the faster movement? It's nothing but person B, because person B, that fellow is covered more distance in a same time, whereas person A covered small distance. The same thing here, in the small interval of time, the rate of the reaction, means in a small interval of time how much the reaction is produced from reactant to the product, this is called as rate of reaction. So we will look at the definition. The rate of reaction is defined as the rate of decrease in the concentration of reactant or the rate of increase in the concentration of product. So it means that the as we look at any of the general reaction, think that here one of the reactants are undergo any of the reactant. When it begins to form the product, the concentration of the reactant decreases and the concentration of the product increases. You just look at some of any of the examples. You take the examples of preparation of tea. If you are preparing the tea, initially you are having the raw materials, that is tea powder, sugar, milk and water. When you mix these all raw materials, the tea will form, but initially you are having this all water, milk, tea powder and all. When you begins to prepare the tea, this raw material will disappears, means we can't able to take that sugar, we can't able to take that water again, we can't able to take that tea powder again, means these all reactants are going to be disappear only because to form the product called tea. Means the concentration of the reactant initially it is more, means we can have the tea powder, milk, water and all everything. When it begins, we are going to lose that reactant because we are going to get the product called tea. So it means that the concentration of the reactant initially it is strong, more, but when the reactions is produced, the concentration of reactant, means quality, quantity, whichever we are having in the reaction, it is going to be decreases. And as the concentration of reactant decreases, obviously the concentration of product increases. It means that you just look at this graph. The left side graph is explains about the concentration of reactant. Initially concentration of the reactant is more. When the time is begins, the concentration of reactant decreases. Similarly, you can just think of this one. While preparing the tea, the quantities are going to be loose. It means tea is forming initially. Therefore, concentration of the reactant decreases. And obviously, in the right side, we can see the graph. It explains about the concentration of product. The concentration of product is increases similarly as the concentration of reactant decreases. So these two are the graph which explains about the concentration of reactant and also concentration of product. Here we have the clear observation that when the reaction is taking place, must and should the concentration of the reactant should decreases and the concentration of product increases. It means that as the reactant decreases, the product concentration will increase. At the same time of interval, how much concentration of reactant decreases, the same quantity of concentration should increases in the product. This is why we are calling that rate of chemical reaction. The rate of chemical reaction is nothing but concentration of the reactant should decrease. Here decreasing the concentration of reactant and also the concentration of the product increases. This is called as rate of chemical reaction. Here square bracket of R in the above way I have given here. The square bracket of R indicates that concentration of the reactant and square bracket of P indicates that concentration of product. So concentration of reactant decreases, concentration of product increases. In this two graph we can justify that the difference between initial concentration, that is R1, that is at a time T1, when the concentration changes when the time T1 is converted into T2, then the concentration of reactant is converted as R2. Similarly, in the concentration of product at a time T1 is P1, at the time P2 is P2. The difference between the time T2 and T1 is commonly known as delta T. Delta T is equal to T2 minus T1. Similarly, the difference in the concentration of reactant, that is delta R, is equal to R2 minus R1. Similarly, delta P is nothing but difference in the concentration of product is equal to P2 minus P1. So before we write the expression of rate of chemical reaction, you should have one important definition, that is instantaneous rate of reaction. Commonly it is called as instant rate. Here instant rate is nothing but, you should remember the previous slide, it explains about the rate of reaction, means speed of the reaction can be calculated for particular time of interval, means initially after 5 minutes how much the rate of reaction or rate of product is changed. That speed is called as rate of reaction. Instantaneous rate of reaction is defined as the rate of reaction at which the concentration of the reactant decreases at that instant, means concentration of the reactant decreases, no doubt, obviously it is decreases. The decrease in the concentration of the reactant, particularly in one point, particularly in one point of time, is called as instantaneous rate of reaction. Here we are defining the instantaneous rate of reaction with respect to the reactant. We may define that with respect to the product also. Same thing here, instantaneous rate of reaction is defined as the concentration of the product increases at a particular instant of time. This is called as instantaneous reaction. So no doubt we can explain the instantaneous rate of reaction with respect to reactant or with respect to the product. But we should not forget that always in an reaction, we should not forget that in every reaction the concentration of the reactant decreases and the concentration of the product increases. So based on that we can able to write the rate of reaction. You just look at this one. Particularly here, consider the general reaction. Here R is nothing but reactant. The reactant is going to give the product. Here the first one is the rate of disappearance of reactant. R is nothing but reactant. No doubt reactant decreases, means concentration of the reactant decreases. Therefore, the rate of disappearance of reactant is equal to the ratio of, means above we are writing that decrease in the concentration of reactant, because concentration of reactant decreases with respect to the time, that is divided by time taken. Similarly, in the product, here concentration of the product increases. Therefore, the rate of appearance of product, initially there was no product, it was 0. Here when the reaction is produced, reactant decreases, product increases. Therefore, the rate of appearance of product is equal to the increase in the concentration of product divided by time taken. Here the rate of disappearance, we have represented that as in decrease in the concentration of reactant. Decrease in the concentration of reactant we have represented in the negative side. Here negative dr, negative delta R divided by delta T. Here delta R is nothing but R2 minus R1, the difference between the concentration of R2 and R1 in a small interval of time, means T2 and T1, that is called as delta T. R2 and R1 is called as delta R. The delta R divided by delta T, where here negative sign of reactant indicates that the concentration of reactant decreases. Therefore, we are showing that negative sign. Similarly, in the rate of appearance of the product, we have mentioned the positive sign, positive delta P divided by delta T. Delta P is nothing but it's a small change in the concentration of P2 minus P1 in a small interval of time, that is T2 minus T1. Here positive sign indicates that concentration of the product increases, whereas in the reactant it is decreases. Therefore, while writing the rate of reaction with respect to the reactant, if you are writing, then you have to show that negative sign. With respect to the product, while writing, you have to say the positive sign. Look here, the rate of reaction can be represented by two methods, that is by using the concentration of the reactant or by using the concentration of product. Rate of reaction minus dr by dt, it is with respect to reactant. Similarly, with respect to the product, it is plus dp by dt. For example, consider the general reaction here. AB is the reactant, capital A, capital B are the reactant, and capital C, capital D are the product. Small a, b, c, d are the coefficient factor. Coefficient factors are nothing but stoichiometric factors. Small a, b, c, d are the stoichiometric factors. Here, just you look at this. Using this general reaction, AB is going to produce a CD product. Here, the rate of the reaction can be represented as first one initially by taking the reactant A. Reactant is nothing but it is A. A is the reactant. Here, the rate of the reaction for this general reaction can be represented as, look here, first one is reactant A. With respect to the reactant A is a reactant, therefore we have to show that negative sign because the concentration of the reactant decreases in a reactant. Therefore, minus 1 upon A. Here, whichever the stoichiometric value is there, here capital A, that is reactant A, is having the stoichiometric value small a. Therefore, what is the value of stoichiometric? It should be taken in the reciprocal. If it is 1, you have to write 1. If it is 2, you have to write 1 by 2. If it is 3, 1 by 3. Like that, you have to write in a reciprocal. Here, the reactant capital A is having the stoichiometric value small a. Therefore, reactant is negative sign. Minus 1 upon stoichiometric value is A, and the concentration of the reactant delta A divided by delta T. So rate of the reaction with respect to the reactant A is only this much, minus 1 upon A delta A upon delta T. It is only with respect to the reactant A. Similarly, the rate of the reaction with respect to the reactant B can be represented, but it is not the sum, it is not the plus. We can represent indivisibly. Rate of the reaction with respect to A is minus 1 upon A delta A divided by delta T. Similarly, the rate of the reaction with respect to the B is also reactant. Therefore, minus 1 upon small b. B is the coefficient factor of capital B reactant. Therefore, minus 1 upon B delta B divided by delta T. Can you see here between reactant A and B, while writing representation means rate of the reaction, I have mentioned the is equal to, it is not the plus, means rate of the reaction can be expressed with respect to any of the reactant or with respect to any of the product, but it is not the sum of reactant, it is never the sum of product, it is simply the representation of rate of reaction with respect to indivisible reactant. That's why I have mentioned the is equal to the concentration of the reactant with respect to A, that is equal to the with respect to reactant B. And next one I have written the rate of reaction with respect to the product. Product is nothing but the concentration of the product increases, that is why plus 1 upon C, small c, because capital C is the product, that coefficient factor is small c. Therefore, plus 1 upon C delta C upon delta T. Similarly, with respect to the product D, plus 1 upon small d delta D upon delta T. Here plus signs of product indicates that concentration of the product increases, and the negative sign of the reactant indicates that the concentration of the reactant is decreasing. By looking this expression, it is possible to write rate of the reaction for any given reaction. Just to look at the examples. So before we move to the next example, I would like to mention you the SI unit of rate of reaction. So here, while writing the rate of reaction, we are using reactant and we may use the concentration of the product. So with respect to reactant and product, we can show the rate of reaction. If the reactants are commonly in the further next in the continuation part, we are giving the preference, means we are explaining the rate of reaction only on the basis of reactant. We may use product but giving the preference for reactant. Therefore, the SI unit of rate of the reaction, if the reactants are liquids, then the SI unit is mole per second. If the reactants are in gaseous compound, then the SI unit is atmosphere per second, because gaseous compounds are expressed in the form of atmosphere. Next one, by using this expression, it's possible to write the rate of the reaction. Just you look at the example here. I have given the example when hydrogen reacts with the chlorine, it's going to give the hydrochloric acid. Therefore our formula is H2 plus Cl2, it gives 2HCl. By using this one, we know that hydrogen and chlorine are the reactant, means they are going to decrease in the concentration, because these two are the reactant, means we have to mention negative sign. The product is 2HCl. The product is 2HCl. The concentration of the 2HCl increases because it is a product. Therefore, the stoichiometric value of H2 is nothing is there beside. Therefore, it is understood it is 1. In the chlorine, the stoichiometric value is 1, whereas in the stoichiometric value of HCl is 2, because 2 HCl is there. So, using this factor, it is possible to write the rate of reaction. The rate of reaction is equal to, with respect to first one reactant, hydrogen. Therefore, reactant is do not have any coefficient value. Directly we will write that minus, because reactant in decreases, minus delta, the reactant name is H2. The square bracket indicates that concentration of H2 divided by delta T. The same thing you have to write is equal to, not plus, is equal to the rate of the reaction with respect to another reactant, that is minus delta concentration of chlorine, that is square bracket of chlorine divided by delta T. These two are the with respect to the two reactant. Similarly, the rate constant of the reaction with respect to product, that is equal to the, here the coefficient value is 2 in the product. Therefore, product increases plus 1 upon 2. The stoichiometric reciprocal you have to write, that is 2 you have to write as 1 upon 2 plus 1 upon 2 delta concentration of the product, that is delta HCl divided by delta T. Similarly, by using this, you can write any of the rate of the reaction. So I hope you understood the chemical kinetic definition, rate of the reaction, instantaneous rate of reaction, and what is the meaning of rate of the reaction, and how we can express the rate of reaction, and importance of chemical kinetics. So therefore, today I would like to give some of the homework based on this. Try to solve this one and try to write the rate of reaction of these questions. And if you are having any doubts, feel free to ask. And still you can't understand, means I request you, please once again watch. If you are feel this little bit fast, just go through once again. And still more doubt, means obviously I will be there with you always to solve any of your problems or any of your doubts. So we will meet in the next video. Until, have a nice day. Bye.